Hey guys, I just want to make sure that you don't have any misunderstandings, so I'm going to go through the notes. You should have already copied these. Okay, I'm not going to handwrite them. They're already written out. At the top of your paper, this is quadratic form. You can rewrite any expression in quadratic form if you can rewrite it without changing it as something squared. And usually I come over and define that something to equal u so that it matches up with this. You should have done number 2 and checked with a friend. Number 3, I kind of showed you how it could be written 2 different ways. 4 squared is 16, or you can just leave the 16 there. That does change your u. That should say u. Sorry, I'll fix that. Number 4, though, you can't do it because if you rewrite x to the 8th as x to the 4th squared, that means this has to be x to the 4th, right? Because it has to be u, and there's no way to make x to the 4th equal to x to the 2nd without changing the problem completely. This is all review, guys. Basically, all of these ways that we've solved quadratics can be used to solve any kind of equation. A cubic, a quartic, a quintic, etc. Alright, so number 1, all I did was I rewrote it like we just practiced. And then what I did was I substituted in, if I let x squared equal u, I can just put u in. Now this looks quadratic, right? So you solve, you get 9 and 4. But remember, x squared equaled u. So really it's x squared equals 9, x squared equals 4. Take the square root of both sides, and these are your answers. This is quartic, right? So remember, this can have up to 4 solutions, and there they are. Alright, number 2 is a little bit different because in number 1 we had to rewrite it using like quadratic form. But in number 2, y'all can factor these right here. We learned how to do these this year. This is a sum of cubes. So I factored it using the formula on the first side of the notes. And then I used the zero product property, and I set both factors equal to 0. This one's easy. We get -7. This one is a quadratic factor. So on the front of the notes, what I added in there was we can solve if we can rewrite in quadratic form, or if the expression has a quadratic factor. So in this problem, this factor right here is quadratic. I love to factor. I tried to factor it again. It doesn't work. So then I just use my handy dandy quadratic formula. So you end up with 3 answers. -7, and then this answer right here, which is really a positive and a negative one, right? So you end up with 3 solutions, which makes sense because it's cubic. Number 3 was a lot easier because when I factor out an x, right, that's the GCF, this is what's left. This is factorable. If you love the quadratic formula and you want a quadratic formula that you can, factoring is easier for me, so I factored it. So I have 3 answers, 0, -5, and -4, which makes sense since it's cubic. Got 3 answers. And then the last one is, I don't know if in Math 1, your Math 1 teacher taught you how to do this, but if I tried to rewrite this one as quadratic, I wouldn't be able to because I can rewrite that part, but not this part. You can't rewrite x as x to the 2nd without changing it. So because I can't do that, what I used was this like handy dandy skill that I have called factor by grouping, and it's essentially GCF 3 times. So you group the first 2 terms, okay, try to find a GCF. I did, it was x squared. So once I factor out x squared, this is what's left, x plus 4. Back here, there's no GCF, right? Just 1. So you bring down the sign and you factor out a 1. But you're really dividing by -1 because it's minus. So when you factor out a -1, this is what you get, x plus 4. Notice these are the same. So that's GCF number 1, GCF number 2. This is GCF number 3. So I'm going to factor that out. This is what's left, x squared minus 1. That is a difference of squares, right? So you've got x plus 1, x minus 1. Use the zero product property, and bam, you get 3 answers, -4, -1, and 1. If you don't believe me, do what we did the other day, graph it. You'll see that this cubic crosses at -4, -1, and 1, okay? So what you're going to do right now is go ahead and take out a piece of notebook paper because you're going to practice. You can work with a partner. It's all for homework, so whatever you don't do is homework. I'll be checking it tomorrow, but I would group up with somebody, work through these examples and the homework. Use this to help you. Email me if you guys have any questions. I should be able to email you guys back tomorrow. So, all right, see you later.